All right, let's dive right in. We're going to pull back the curtain on the invisible blueprints that make our entire digital world tick. I'm talking from your living room all the way to the entire planet. So, what do your home Wi-Fi and the entire internet have in common? I know it sounds like a trick question, right? One's this little box in your house, the other, well, it's the whole world. But here's the thing, they both run on the exact same fundamental design principles. These are the invisible rules that decide how everything, and I mean everything, connects and talks to each other. And that blueprint, it actually has a name. It's called network topology. The best way to think about it is like a city plan, right? You can't just start throwing up buildings and roads wherever you want. You need a master plan, a blueprint that shows how it all fits together. For our digital world, network topology is that master plan for all our devices.
Okay, so to really get a handle on where we are today, we've got to go back to the beginning. We're talking about the simplest designs, which, as you're about to see, were also the most flawed. Think of these as the first drafts of how to build a network, They were really born out of what was possible at the time.
So the first two big ideas on the scene were the bus and the ring topologies, and you have to put yourself in that mindset. Back then, every single foot of cable was super expensive. Every network card cost a fortune. So the whole game was about one thing. How do we get these computers talking to each other using the absolute least amount of stuff? First up is the bus topology. It is dead simple. Just picture a single main street. That's your main cable, and every single device, let's call them houses, connects right onto that one street. Super cheap, super easy to set up. But it's got this one massive hidden flaw. And there it is, that's the Achilles heel. If you get a break anywhere on that main cable, the equivalent of a car crash blocking that one main street, the entire neighborhood is completely cut off. The whole network just dies. All right, so people saw the problem with the bus and thought, okay, let's try something else. Enter the ring topology. The idea here was to get rid of that single point of failure. So instead, each device connects directly to its two neighbors, forming this perfect continuous circle. Data just passes along from one device to the next, all the way around the ring. But yeah, as you can probably guess, it was a different shape, but it had the same old problem. If just one of those links breaks or one device goes down, the whole circle is broken. And boom, all communication just stops. It was back to the drawing board. So it was pretty clear these early designs were just too fragile. Engineers needed something way more robust, way more reliable. And that pressure led to this huge innovation, a design that pretty much dominates our networks today, the star topology. And the idea behind the star is it's brilliant in its simplicity. Instead of connecting devices to each other, you connect every single device to one central point. We usually call this a hub or switch. Think of it like the hub of a wheel. And by the way, that Wi-Fi router in your house? Yep, that's the heart of your very own star network. Now, here's the magic. This is the real game changer. If the connection to, say, your laptop goes down, who cares? Your phone, your TV, your gaming console, they all stay online because each one has its own separate connection to the center. It isolates the problem. This makes the whole network so much more reliable. And that's why the star just took over. It became the standard. And it wasn't just because it was more reliable, it's also way easier to manage everything from that one central spot. And want to add a new computer? You just plug it in. It's incredibly easy to expand. It just works. But what if really good isn't good enough? What if you're building something where failure is just not an option? I mean, a network that absolutely positively cannot go down. Well, for that, we have to look at a totally different beast, the mesh. Before we even get into what it is, just look at that number, 190. That is how many individual cables you would need to connect just 20 devices in what's called a full mesh network. Yeah, that number alone should tell you we're diving into something seriously complex and seriously expensive. So what is a mesh topology? Well, the principle is simple, but kind of insane. It's connect everything to everything else. Every single device has its own direct, dedicated connection to every other device. It creates this incredibly dense web of connections. And right here, this is its superpower. If one connection fails, no big deal. If 10 connections fail, still not a problem. The data is smart enough to just find another way to get where it's going. This network can literally heal itself.
And you know what? This is the core idea behind the internet itself.
Okay, so let's recap. We've got the simple but weak designs. We've got the solid, reliable star. And we've got the ridiculously complex but bulletproof mesh. So the big question is, what do people actually use in the real world for something big like a university or a huge company? Well, the answer is we kind of cheat. We use what's called a hybrid topology. Now, this isn't some brand new shape, it's more of a philosophy. It's about taking the best parts of all the others and mashing them together. So you might have a few different departments, each with its own star network, and then you link all those stars together using a bus. See? Best of both worlds. And really, this is the key to all modern networking. The hybrid approach lets you build a totally custom solution. You can balance the cost, the reliability, and how big you need it to get, all based on what you actually need. It's not a one-size-fits-all t-shirt, it's a perfectly tailored suit. All right, let's wrap this all up with a quick cheat sheet. You can see all the trade-offs right here. Bus and ring, super cheap, but you can't rely on them. Star, that's your sweet spot. Great reliability, easy to expand for a totally reasonable cost. Mesh, that's your top tier, ultimate reliability. But man, is it expensive and hard to scale. And then there's hybrid. That's the choose-your-own-adventure option that gives you all the flexibility you need. So there you have it. These invisible blueprints are literally all around us, silently running our entire digital lives. You've got a star network sitting in your living room, and you're consuming this right now thanks to a massive, complex system of hybrid and mesh networks. So now that you know what to look for, which of these blueprints do you think are powering your world?